All right, hello everyone. Thanks for making it out, and I hope you've had a great Google Cloud Next so far. I'm Cameron. I'm the product lead for the Go programming language at Google. I'm here with my colleague Gary, product manager for GKE. We're here to show you why and how you can use Go to build reliable, production-grade AI applications, including on Google Cloud. So before we get started, a second about us. As I said, I'm the PM lead for Go. I've been on the Go team for about 4 years. Prior to Go, I led product for the Google Cloud SDK, including language and framework integrations. And before Google, I was a software developer at a high-frequency trading firm, where I worked on low-latency trading systems, almost all of that in C++ and a little bit of Java. And now I'm a Go convert. You know, the stuff we'll discuss today is just a small part of why I like Go a whole lot more than all the other stuff I've worked with. Gary is a product manager for GKE, but he's also far more technical than most product managers and even most software engineers, which is why it's really great when he agrees to co-present with you at Cloud Next. Before Google, he worked at a private equity firm, and before that, he was a distinguished engineer at IBM for more than 15 years. Gary is also a huge fan of Go, but he's been a fan from the start. And he's the real attraction to this presentation, so if you find yourself bored, at any point, just sort of push through for that second half. Okay, real quick. How many of you use Go today, either yourself or through your teams? Awesome, so almost everyone. I've given a lot of talks on Go, but today's talk is kind of extra special because I have with me a good chunk of the Go team in the audience. We even have Robert Griesemer here. Robert is the co-creator of Go, along with Ken Thompson and Rob Pike. I think he gets a little uncomfortable when I put too much attention on him, so I won't point him out. But you can find him at the Go booth in the Innovators Hive on the expo floor later. I think Robert may be giving autographs. So all of you know what Go is, but I think it's still helpful to tell you what we, the Go team, think Go is and how we look forward from there. And the first and probably most important point I want to make is that Go is not just a programming language, it is a complete end-to-end platform for building production systems. This has been our vision from the very start, to facilitate real software engineering at scale. That sort of software is written in teams, where members come and go, where you have deadlines, SLAs, all of that. And internally, we reduce that vision to the mission statement that I put in the title of this slide. Go provides the most productive platform for building production systems. It's productive because it's easy to learn and maintain and scale across teams. It's a platform because it's more than a language, it's an end-to-end developer experience. This includes IDE integrations, build and deployment tools, monitoring tools, vulnerability scanning, runtime tools, all of it out of the box. And it's production ready because it's reliable, efficient, stable, and secure, which is why you'll see it all over the enterprise, especially in critical business systems and infrastructure. And it's also why the modern cloud itself was built on Go. And by that, I mean not just Google Cloud, but AWS, Azure, and all the other major players in cloud tools and technology. So thinking about that some more, how many of you are familiar with the DevOps infinity loop diagram on this slide? Okay, yeah, I think it's a decent way to think of the broader software development lifecycle. You can think of the loop on the left as the inner dev loop, where you're writing your code, iterating quickly, looking for quick feedback and productivity. And then you can think of the loop on the right as the outer loop, the one where you deploy your code into production and then monitor and operate it. So when we think about the Go platform, we think about solving end-to-end across this whole thing, inner and outer loops. So I'll make the point with some examples. Let's take developer velocity. Go has features and tools and libraries that take everything into account to maximize your team's developer velocity, from when they're writing their code to pushing it into production and then operating it reliably thereafter. We provide IDE integrations, including our own plugin for Visual Studio Code, to make it easy to leverage the features of the rest of the tool chain. We provide a powerful concurrency model through Go routines. We have built-in formatting, a built-in test framework, a built-in debugger. The Go compiler itself builds static, standalone binaries with no system-wide dependencies or a separate runtime, which makes deploying easier, safer, and faster than in other languages. It's an end-to-end solution for gaining and maintaining developer velocity. Next, let's take security. Go is a really well-known leader in security, which we also address end-to-end. If you've been following the news on the latest XZ software supply chain attack, you'll know, how important this is, and perhaps more important than ever. This is one area that we've taken extremely seriously because we've seen what can happen in other language ecosystems when a popular dependency is compromised. And because Go is used in so much of this critical infrastructure in the cloud, we recognize that security is among the very most important things that we provide. So this starts with our dependency management system, where the Go module mirror, checksum database, and package website at pkg.go.dev warn you if a library that you depend on is tampered with or suffers from some known vulnerability. How this works is actually super interesting, but it's beyond the scope of this talk, but there's a lot of stuff online that I encourage you to check out. Our IDE integrations go deep. If you use our plugin for VS Code, you're alerted to vulnerabilities in your dependencies right there in the IDE, including whether or not your code actually invokes the vulnerability in the dependencies. So this way, you know about the security posture of your dependencies, whether they affect you, all of that, before you rely on them in production. Go is also the only major language with fuzz testing built into and integrated with its toolchain. For those who don't know, fuzzing is an automated type of testing which intelligently manipulates inputs to your programs to find bugs and vulnerabilities. And Go's compatibility promise, where we ensure no breaking changes starting all the way from Go 1.0, means that upgrades are easy, which means staying up to date with security fixes and enhancements is easy too. So we built on this a little bit more last year in Go 121 with forward and backward compatibility features. We really think of compatibility as more than just a convenience. It's a critical security feature. And the last example I'll walk through is performance. Go's standard library. It's rich and robust and optimized for performance. You can build anything on top of it without having to import some heavy framework. Profile-guided optimization, which was just released last year, enables you to profile your application at runtime using something like the Linux Perf tool or Google Cloud Profiler, and then you feed that output back into the compiler for a subsequent build. So now that the compiler knows about your application's runtime behavior, it can tailor its optimization accordingly. So you get something like a JIT in an ahead-of-time compiled binary. Customers who've used this love it, and some have seen some really impressive CPU performance improvements. We also have a self-tuning garbage collector. If you've ever spent time tuning the garbage collector in Java, you know that it's like a full-time job. It can take as long as it did to write your code. In Go, the garbage collector is performant out of the box and then self-tunes to fit your workload's needs. And there's a ton more, all of which fits in this framework of end-to-end solutions out of the box. And that's what makes Go the most productive platform for building production systems. And we do all of this with really extraordinary feedback from our users. For the most part, Go users really love Go. We consistently see really high customer satisfaction in our surveys, like levels that are practically unheard of in the industry. So I'll close this section with just a quick overview of how we position these features in Go as value to you. So in these 4 rows, you can kind of think of this top row as stuff related to productivity. It's quick to get started, quick to iterate, quick to build real scalable production applications. That all translates into faster time to value for you. The second row, it's about reliability, which includes security and compatibility and all the stuff that reduces your long-term maintenance and operation burden. So the less of that burden, the lower your total cost of ownership, and the more time and resources you have to focus on the new stuff that grows your business. This third row is about the cloud. Go is purpose-built for the cloud. The libraries and integrations and architectures that Go enables, they were meant for the cloud. They weren't retrofitted for it later. So this means that you can realize the cloud's benefits faster and easier than you can in other languages. And finally, Go users are happy. They're happy everywhere, and they're really happy on Google Cloud as well. And I think everyone likes happy developers and operators. Okay, so that was a lot about Go, but we promised you a little bit about AI, so we'll do that now. So, AI, or like generative AI in particular, is obviously new, and I think a lot of the norms have yet to be established. But one thing that we've all seen is that Python has done really well in every aspect of AI. And that's because Python is the language of data scientists. It's great for working with data, developing models, using its rich ecosystem of data science libraries. And if you simplify the AI process into these 3 steps on the right of the slide, so data work, modeling work, and production serving work, Python really is the best tool for the job for this part in blue, the part where you're building models and fine-tuning them and exploring them further. But the other parts of this cycle, data processing, data preparation, model serving in your product, this is the stuff where you need a production-grade language. And here, Python isn't really the right tool for the job. It's not really meant to scale. The features of static languages like type checking, compilation of machine code, all those things, those are the things that enable scaling to large programs, large development teams, and large systems. In fact, production systems require their own ecosystems of libraries and tools to enable their developers and operators to really work effectively at scale. And this is where Go shines. Reliability and security, performance and scalability, low maintenance and operational costs. This is where Go is the right tool for the job. So perhaps not surprisingly, Go developers think this too. Many of them have started writing AI-powered applications in Python because that's what the tutorials online are doing and what many early SDKs focused on. But they hit a wall once they want to go to production. So we on the Go team have been working hard to kind of show them the way. And one way that we've been doing this is by building our own AI-powered applications, experimenting with ways we can enhance the Go developer experience itself with AI. So we've tried things like using Gemini to summarize vulnerability reports, which today takes a lot of time from dedicated security developers on our team. And we've also thought about tutorials and tools to get started. So just last week, we introduced Gemini and LangChain templates for Go in IDX, which, if you don't know, is the browser-based AI-powered IDE from Google. And we also thought about how we can improve the Go package site. So one idea we're prototyping is a similarity feature, where for every package you look up on our package site, you can also get a handful of similar packages as suggestions to check out, where similarity is determined by an AI. So let's take a closer look at that. The architecture of our package site today is actually rather complicated. It looks something like this diagram on the slide. And it's centered around this Postgres database that reads from our module mirror. But for purposes of this demo and explanation, let's forget most of this and focus on the stuff in blue. So the database where all the entries to pkg.go.dev are kept, the front end, which runs the Go application that serves the package site, and then the client-side application in the browser, and the Go for using it. So these 3 pieces come together to show us something like what we have on the screenshot on the right. For every package you look up and click into, we have the README, the documentation, source files, et cetera. Now, to add this similarity feature, we want to use a vector database. So unlike a relational database, which stores a bunch of rows and columns, which represent attributes of the row, a vector database stores all the data as vectors of floats. So in our case, we're going to take the data from the relational database, transform it into vectors, and then store it in a vector database that the application front end can draw from. And we'll create something like the screenshot on the right, a section in the listing of a package on the package site that lists a few packages similar to the one you're looking at right now. So let's walk through it. First, we need to populate the vector database with data from the relational database. To get these vectors, we use what's called an embedding model. So an embedding model is an AI model that transforms any kind of data into vectors that are usable by a vector database. So to generalize that for a second, think of all the data you might have, images, videos, text, whatever. You feed that stuff into an embedding model, which encodes that data into vectors that go into the vector database. And the vector database, in turn, keeps similar objects clustered together. So applying that general description here, we want to take all the data from the packages on package.go.dev, which for simplicity here, we're just dumping into a JSON file, but in production, we'd want something a little less hacky. We feed that data to Gemini's embedding model on Google Cloud, which spits out all the embeddings that we also capture in another JSON. And then we give that output to our vector database so that we can run queries on it at runtime. So looking at this diagram again, we want to add Gemini right in between our relational database and our vector database as this transformation step. And this is how we're going to turn the relational data of all the packages on package.go.dev into their vector representations. Now, for simplicity, instead of giving the embedding model all the data of a package, we're just using the package doc field, which is that chunk of data at the start of most Go packages. But you could imagine how we could potentially get better results by providing other stuff, like readmes and function signatures for each package. With all that data in place and available to read from our JSON file, now it's time to feed the package docs into Gemini's embedding model. So I'll just touch on a few of the key lines here so you know what to look out for when you want to go do this yourself. The top arrow points to our import of the Go SDK for Gemini. At the second arrow, we create a new Gemini client using an API key, in this case one that we pass through an environment variable. After we create the client, we specify which model we want to use, which creates an embedder object. So we do that at the third arrow. Right after we created the client, we specify embedding 001. And then finally, at the last arrow, we call the embedder objects embed method with the data we got out of the packages.json. Then we return the vector we got from Gemini and write it to disk. So the file we wrote looks something like this. The embedding as well as some other metadata like the ID of the package. We now have the embeddings.json file that we're going to now want to load into the vector database. So to do that, we go to Vertex AI Vector Search on the Google Cloud Console, where we create a new vector database index, which we populate by pointing to a cloud storage bucket where we've uploaded this embeddings file. Then we create an endpoint that allows us to access the index we just created. This endpoint is like an address that our program can use to query the index. And that's it. Now we have our index. So we take note of the endpoint address because that's how we're going to use this endpoint going forward. OK, so at this point, we've populated our vector database, and we have our index, and we've deployed it to an endpoint, and we have the endpoint address. Now we want to do the other side of this, the part where a user can query the database. So here, we're going to get the query from the user. Then we're going to look up the relevant package, feed that individual package doc into Gemini to get an embedding, and then use that embedding to query the vector database. So it's almost exactly the same thing we did to populate the index, except this time we're only doing it for an individual package, and we're not writing anything to the vector database, we're just querying it. So remember this diagram from earlier, it's almost exactly the same. The difference is that now we're only feeding it data from one package, the one the user queried, and Gemini is only going to give us one embedding because we only gave it one package. Great. So once again, let's take a look at some of the key pieces of the code that does all that. Our user only provides us the name of the package she wants to query, so we need to get the package docs ourselves. In this case, we grab it from the packages.json we created, but in a real-world use case, we'd query the relational database. We then call Gemini, then wrap its results into an API call to our vector database. So the key things to look out for here. First, the API endpoint address, which we store as a const at the first arrow. Second, the call to Vertex AI to create a new client using the API endpoint address. The request itself, third, which specifies a few restrictions on the kinds of results we want. For example, the number of times this result that it's going to suggest has been imported somewhere else. And then the search itself at the fourth arrow, which we return in the end. All right, so that's the baseline stuff to whet your appetite. At this point, you should know why you want to use Go to build production AI applications. And you know that you can through the Gemini and Vertex SDKs. Now let's show you how to do some really interesting stuff on top of that. Are you good?
We got to log in real quick here, Google Security. skip that slide.
Yeah, I don't think I can get that. All right.
1 second, sorry about that. All right, so how many of you are have built any AI applications, familiar with like the Python models, Hugging Face? Great. So as Cameron and I have been talking for a while, we've been buddies for a while, talking about sort of Go, and I've been doing a lot of this stuff on the GKE side as well. I said to myself, is there a way to do all this in Go, right? We've been getting to Go for production apps, and then AI came back, and I found myself surrounded by Python, which is fine, but can we do stuff in Go? So I said, can we find an entire stack out there to sort of build an application? So started to think of a few ideas. So one, let's start with a simple sort of demo. Cameron talked about this like sort of package site idea that we had. Here's a command line version of this, and I'm just going to run it. He showed you the source code, but essentially what this is doing is saying, we've kind of decided that we think that the most interesting packages to like CockroachDB are the top 500 importers of it, right? That's how we're going to assign relevance, right? So run this demo, and hopefully it still works. Yeah, and this did the exact same thing. Queried the vector database, got our packages right, and you can see the number of sort of importers in there. So that's kind of cool. And then said, well, what if we wanted to build sort of a chat application? And did folks listen earlier? You know Gemini, and have you heard of Gemma? Did you guys hear of Gemma this morning, right? So Gemma is our open weight model, right, available for you to host yourself and sort of serve. Now, there's lots of ways to do this. Generally, there's lots of frameworks out there. Turns out that there's a pretty cool Go-based framework, actually, and it's called Ollama. Has anybody heard of Ollama yet? All right, so Ollama is awesome, written in Go, basically uses CUDA, C on the back end, CGO. So I've got a hardened front end server, right, to basically serve in my requests. It's loading up the CUDA kernels, on the back end. A great framework. So in our case, I'm actually running, I won't show it to you, but because I'm a GKE guy, so I'm running Ollama on the back end of GKE. So Ollama has this great client. So I said, okay, this is kind of cool. Let me connect to, hold on. There we go. Let me connect to kind of Ollama, and let me see if I can do this sort of chat interface. So over here, we sent a query in that said, CockroachDB, and this is basically saying what are the top packages. Now, LLMs are pretty cool, right? So what if I say top packages related to CockroachDB, right? So this is, a Go client talking to the model on the back end, and, pretty cool, right? It's working. This is an LLM generating my sort of messages. But I said, well, that's cool, but it's just kind of, if you know what text generation is, it's fundamentally just predicting the next sort of token that's out there, looking on sort of information. Now, we've decided that the way that we want to measure the success of a package or whether it's ranked is based on this sort of ranking. So how can I put these two things together? How many folks here have heard of RAG? Great, right? And then how many folks have heard of LangChain? How many folks have heard of LangChain Go? See, but you didn't know that. But so yeah, on my desperate hunt to avoid using Python, I typed the words LangChain and Go and found out that there was something called LangChain Go, which is a fantastic package. So now what we can do is, our whole goal here, right, is to orchestrate these two things. So what do we really want to do here? We want to take this data, right? So we've got our packages that we've returned from the vector database. We want to sort of add those in as the context that we're going to pass into our model, Gemma, on the back end, and then hope that it uses some magical LLM stuff and generates a nice textual response, right, given this sort of chat application. Now, my goal here was not to build the most complex chat application. And actually, one of the things that people say about LangChain is that it's super simple. You don't have to do anything. Now, Go is super simple as well, but let's take a quick look. So nothing special here. We've got our package here is this vector-db package. This is basically, I'm just importing the same code that I used in the command line application, right? So it's doing the vector search and taking that in. And then the nice thing about LangChain Go, again, it has this sort of standard interface, right? So it's just implementing LLMs, and it defines that as an interface, and basically you can have multiple kinds of LLMs. And it supports, Gemma, Ollama, ChatGPT, like a ton of them, right? So this makes it really easy for you to basically just create whatever you want as the one LLM and then write your sort of application. So again, this is really simple Go application, but the goal here is to show how easy it is to write an AI application in as few lines of code as possible. So our command line app is going to be really simple. We're just going to put in our chat, get that. We're using Gemma 7B because, that's our model. I could use any open weight model here, right? If I chose to use, Mistral, Falcon, whatever, I can sort of just replace that. Again, very much like LangChain Go or LangChain or any other language, you have a simple constructor here, right? That's going to give us this LLM interface. And basically here, I'm just saying, here's the model I want to use, and then the URL. Again, I could run this locally. I'm just running this on GKE. So in minimal lines of code, right, I'm basically connected. I have a client, and I'm connected to a model hosted on the back end remotely. Now, what do we really want to do here? So our goal, how many folks are familiar with like prompt engineering and passing in context, right? So, I mean, as you know, it's really like RAG is a fancy word for getting a bunch of information and shoving it into the prompt like ahead of time to give that sort of hint, right? So what we're going to do is on the back end of our prompt, so we know that our format here, for example, because I'm being lazy and just using existing code, I know that I'm getting a table, right? This is essentially a tabular result, right? So I'm going to use on the back end, we're going to take this in on the chat. We're going to run the query here. You can see on the prompt context, and this is going to return the results from the vector database. Then I know that's going to be in a tabular format. And now I'm going to orchestrate that with a prompt internally where I'm going to say, given the following table, list the full package URL and give me a summary of that package. And then I'm going to shove in the context. Now, you can do this in fancier ways or whatever, but this is basically the most sort of simple model. And then the main thing about the LLM interface is that every single one of these basically has it basically tells you to implement the generate content, right? So essentially, that's really the interface that LangChain and LangChain Go uses for that. And then we're going to complete, and that should do it. You can see from the query perspective, we're passing in the same options here, just so you know, like in the CLI, we were basically saying it's 500, if you're imported 500 times or more, you're a decent package. All right? So if all goes well, again, I'm just passing an environment variable to my back end. We're just going to run our chat application. Again, the other great thing about Go, as you all know, similar people like Python, because you can run Python, just run it. This is going to take no time to compile. And if all goes well here, I should get kind of a nicely formatted answer where things sort of match what I got in the CLI. And that we should have our application built pretty quickly. Oh. All right, so we'll give it a run. So you can see here we're basically running the stuff as Cameron said. We're querying, we got the back-end stuff, we got 8 packages. And now, similar to our previous, if you can see that, similar to our previous chat result, we're getting kind of a nicely formatted answer, but our results more closely match. See, we have CRDB here, CockroachDB. They more closely match what we had over here, as opposed to, say, like the raw chat, right? And in the end, that's pretty much the magic of writing an application as quickly as possible in Go. So TLDR, there's a full framework for serving written in Go, and there's a full framework for orchestrating written in Go. And you can copy all the same models and all the demos that you see out there. You can easily translate those to Go just in this simple mental model, and you'll be up and running, and we'll all be happy. With that, let me pass it back over to Cameron to take us home.
All right. See, I told you that was the better part. And this was a slide we would have showed you before, but kind of this is how we modified the architecture here with Gary's example. All right, so if any of you want to try any of this stuff at home, Eli Bendersky from the Go team has a series of blog posts that are a lot of fun and track most of what we showed you today. Just scan this QR code to get started. And you can always check out the Go documentation for Vertex on the Google Cloud website for official docs and examples. And that's it. So before we take questions, please remember to give us any feedback in the Cloud Next app, good or bad, but especially good. And thank you.